Many storms have produced areas of damage that far exceed the official Saffir-Simpson classification. But now it has become apparent that the outer eye walls and feeder bands of hurricanes are much more complex than previously thought. In this radar sequence of Hurricane Katrina as it made landfall on the Mississippi coast, notice the intense red areas in the eastern eye wall. These areas are known as collapsing cores. A collapsing core begins as a mass of precipitation suspended at 10 to 15,000 feet, well above the highest winds in the hurricane. Dr. Keith Blackwell explains.
These collapsing cores can be identified by looking at digital radar data from the Doppler radars, for instance, along the coastline. We can use 3D depictions. We can use various software to develop 3D images of the development of these heavy precipitation areas within the storm up maybe at 10, 15, 20,000 feet above the ground. These collapses of precipitation down through this very strong wind in the eye wall can help bring that wind down to the ground in very, very strong gusts.
In Katrina, there were radar-documented cases of collapsing cores where highly destructive winds were brought down to the surface. In this image, the collapsing core is located at an elevation of approximately 3,000 feet. The collapsing core, shown in red, is located well above the maximum hurricane winds. The Mississippi coast is on the left and the Mississippi Sound on the right. Watch as the core collapses to the surface of the Mississippi Sound, dropping more than 10,000 feet in just 12 minutes. During its rapid descent, the core transported the highest hurricane winds down to sea level. In another three-dimensional view over Mobile Bay on the same morning, a collapsing core can be seen embedded in a feeder band over the eastern shore of Mobile Bay. From an elevation of 5,000 feet, the core, in red, dropped to the surface in just 6 minutes. This collapsing core brought winds in excess of 120 miles per hour to a small area along the Mobile River, more than 100 miles from the center of Katrina. Collapsing cores can contribute to the complicated damage pattern that results from landfalling hurricanes. In this microwave image, Katrina displays an open eye wall over the southwest portion of the storm as dry air enters the system. Research has shown that collapsing cores seem to be more common in hurricanes that have open eye walls, such as Ivan and Katrina shown here. Collapsing cores were not the only destructive wind producers in Katrina. Numerous tornado-like vortices formed in the eye walls and in the feeder bands over the Gulf and across Mississippi. Dr. Pat Fitzpatrick explains.
A mesocyclone is a rotating thunderstorm. We know about 20 to 30% of mesocyclones produce tornadoes. If you look at the radar imagery from Mobile, Alabama, and Slidell, Louisiana, you see about 100 to 150 of these mesocyclones. But we also have a reason to believe that, particularly in the Mississippi coast, that some of these mesocyclones were also missed as well. The reason for that is the radars are not in this location. They are 50 to 100 miles away or more. And because the earth is curved, you don't necessarily see the cloud base. Most tornadoes and hurricanes are very low-level events. And because the cloud base is low, we know also probably a lot of these mesocyclones were missed as well as tornadoes.
Now let's take a look at each of these rotational features along the Mississippi coast and inland as detected by Doppler radar. First, tornado vortex signatures that show possible tornadoes. Next, mesocyclones or rotating thunderstorms. Now three-dimensional correlated shearing events that show rotation aloft with considerable depth. And lastly, other uncorrelated shearing events. As is evident from this map, there were hundreds of rotational features spawned by Hurricane Katrina, but not all of them were detected by Doppler radar. Many of these contributed or had the potential of producing major wind damage. You have just witnessed an in-depth study of a very unusual hurricane. Katrina was one of those rare hurricanes in which everything came together: the shape of the coast, the funneling of the storm surge, the extreme power of her winds, and most importantly, the double eye wall structure. For it was the double eye wall structure that made Katrina a monster storm and put strong hurricane force winds and vortices on the coast well before the record storm surge arrived. Then, as if that wasn't enough, Katrina produced numerous collapsing cores and rotational features that brought extremely high winds from aloft down to the surface. Despite a massive area of Category 5 damage in Mississippi and Louisiana, Katrina will officially go down in the record books as a Category 3 storm at landfall. Thus, Katrina clearly demonstrated that there is a serious flaw in the widely used Saffir-Simpson scale. We've come a long way in the last few decades in our ability to forecast and monitor hurricanes, and in the process, we have saved thousands of lives. But as is usually the case in nature, there's still a lot to be learned. As our research has proven, accurate assessment of the causes of storm damage requires post-storm analysis and evaluation of microwave satellite imagery, as well as a detailed review of all recorded storm data. By identifying and recognizing the power of the double eye wall, collapsing cores, and rotational wind events, it becomes clear that the winds of Katrina produced extensive damage before the waters came ashore. I'm meteorologist Dr. Bill Williams.